Okay, so remember I told you that there's 3 different forms for quadratic, right? We talked about the vertex form. How does the vertex form work? Y equals
x squared, y equals a, bracket x, that way.
Right? That is the vertex form. So whenever you see something that written like this with values for a, h, and k, then you know it's the vertex form. Now the standard form is written this way. So y equals ax squared plus bx plus c. So it's what you just saw when you did your FOIL, right? When you did the FOIL and you did the thing, you ended up with, let's say, 2x squared plus, don't write this down, okay? When you did the FOIL, this is what you're gonna what you ended up with: 2x squared plus 3x plus 1, let's say, right? You ended up with this, something like this, yeah? This is called the standard form, okay? It has ax squared plus bx plus c, okay? So the question is, how from vertex form to standard form? We go through what we call expanding. So we're expanding it, okay? So it kind of follows the same thing that we just did with the foiling, but it's a little bit more advanced than that, okay? So let's look at this question. Look at these 2 graphs. What can you tell me about these 2 graphs? I said graphs, don't look at the equation. Look at the graphs. They're the same? They're the same? Yeah. You see that? What's the vertex for both of them?
2 and
2 and 1? Yeah. And what is the y-intercept for both of them?
6, so it's 6?
5. 5. Right? So they both have the same y-intercept. They both have the same vertex. They both open up. They both don't have any x-intercept. So they are the same. They are exactly the same graphs. Okay. Now look at the equations. What can you tell me about the equations? They're different, right? But they both represent the same equation. Okay? They both represent the same graph. But one is written in vertex form, and the other one is written in standard form. Okay? So this is the vertex form. This is the standard. Now, if you're looking at the vertex form, what can you tell me? Where's the vertex? 2 and 1, right? That's what we see here as well. 2 and 1. Okay? So I was able to figure out the vertex right away from the equation. I didn't have to think too much about it. Okay? Now, anything else that you can tell from the vertex form? Step pattern, anything else? Optimal value, which is 1. Axis of symmetry is 2, right? But we're still around the vertex, which is 2 and 1. Okay, nothing else. Now look at the standard form. Anything in that graph is indicated in the standard form. That's a hard one. It is. The y-intercept. Where do you see the y-intercept? The 5. Right? So the last number in your standard form, which is the C, this one, right, represents the y-intercept. So from the equation of the vertex, I can find the vertex. From the equation of the standard form, I can know what the y-intercept is.
So the y-intercept on the second side is 5?
That's right. basically, knowing one is great. Knowing all of them is awesome because then you know everything. You can tell everything about your fraction. Okay? So let's look at the equation. So an equation that is written like this: y equals ax squared plus bx plus c, and it tells me the location of the y. Which is the value of the letter C, right? So that is the value. Now an equation in vertex form, how does it look like? Y equals A x minus h squared plus k. Tells me the location of the vertex. Other than the vertex, what else? Optimal value. And axis. Okay? So, it's important to know how to go from one to the other. In this course, we only learn how to go from vertex to standard. We don't learn how to go from standard to vertex. In the 3M and in the mixed course, Arvin, you learn how to go backward. So in the mixed course, you're going to learn how to go from this form to this form.
Can you scroll a little more? I think it's top right.
Don't write that. Okay? All right. Now, to go from vertex to standard, we have to expand. Okay? Vertex form can be converted to standard form by expanding. You guys have to learn these terminology because the question will be asking you to expand. The question will say expand. Stop. Period. That's it. You're done. Expand. Do it. Okay? It will not give you any other explanation. Okay. Do you see this?
Yeah.
Have we done something like this in the previous lesson?
Yeah.
What did we have to do?
Expand. Like we have to clone it.
Clone it, write it twice, yeah, and then expand. Now what happens to that plus 1?
Save it.
It moves to the back.
And negative.
You're going to save it till the end, and then you're going to add it with your like terms at the end.
Yeah, got it.
Okay? So we're going to have to do what we exactly did in the previous in the previous lesson. So clone this. Keep that plus 1 on the side. Okay? Keep it with the equation. Don't touch it yet.
You have more right.
And let's expand. So, for x times x, negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. And then plus 1. Do you see that? So all what I did up to here is I did the FOIL, right? So I multiplied the term by the term by the term, right? I did it twice. Okay? Now what do you see? I have 5 terms. Negative 2x minus 2x is negative 4x. And then these two are like terms. So I have to add them. Is that okay? Okay?
move back up a little bit and get the blanks?
Sorry?
Can you move back up a little, just a little bit with the blanks?
Now, first question, we have to do it on the next page, so I don't know why when it somehow it just copied on this side. Okay? So this question belongs to the next page. Oops. I like when this doesn't work properly. Okay, we're gonna work on it next page.
Just give me 1 second. Guys, let's get your answer.
Okay. So, what form is this in? Vertex form. Okay? So the first question is asking you to state the key features you can determine from the vertex form. So what can you tell me from the vertex form? What's the optimal value?
4.
Negative 4. Is that max or min?
Yeah.
Why is that min?
That's not pink.
What?
It's negative, I guess.
Which way does it open?
Down.
It opens down, right? Because A is negative. So is that minimum or max?
It's not.
Okay. So it's a max. Okay, so optimal value of y equals negative 4. What else can you cover? Axis symmetry is what? What is it again? Sorry, exam. So x equals negative 1. Okay? What's your vertex?
1 and 4. Negative 4.
Not 1.
Negative 1.
Negative 1 and negative
Negative 1.
Okay. Right? So these are the key features that we know from the vertex form. Right? We know that this is our vertex, negative 1 is the opposite of what we see, and negative 4, we know that this is the axis of symmetry, which is the negative 1, and we know that the optimal value is negative 4, we know it opens down, and we have a max. Lots of information there, right? Now they want you to expand in the second part. Expand. Now you see that it's not only the x plus 1 squared minus 4, I'm also multiplying by negative 3. Okay? So first thing, you're going to do your bracket. So you're going to clone this, x plus 1, do your expanding first. We're going to do the expanding. Okay, we're going to do the fourth. Can you guys help me with the fourth? What do I get? X times x is x squared plus x plus minus 4. Okay? Are we okay up till now? Now, what else do I have to do? What do I have multiply that negative 3 in? You remember the distributive property that we see right here? We have to do it again here, but we have to do it to all the 4 terms that we see inside the bracket. So we have to multiply negative 3 by every single term inside the bracket. So that's negative 3x squared minus 3x minus 3x minus 3, and then take away 4. The 4 is untouched yet.
So just add
now collect like terms, right? So what are your like terms?
3x and 3x.
So the negative 3x and negative 3x.
And here negative 3.
That gives me negative 6x. Gives me negative 7. So what are the key features that I can find from the standard form? The y-intercept only. From the standard form, which is this form, I can only find the y-intercept, which is
7.
negative 7. Very important to know what form are you looking at and what each form can give you, what information can each form give you, because later on when we do word problems, if they ask you for the maximum value or for the optimal value, which form do you want it in? Vertex, because vertex gives you your optimal value. If they ask you for your initial or your y-intercept, which form do you want it to be in?
Standard.
Standard. So this will kind of help you, knowing which vertex tells you what, which form tells you what, kind of help you answer the questions later on when we do word problems. That's correct. The factor would give you, the factor 1 would give you the zeros, which are these 2 points right here. Okay? But we'll talk about that in the next couple of lessons. Okay? So, for now, what I want you to do, I want you to work on these questions, please. Okay? Expand them. Do